Ladies and gentlemen, hello and welcome back once again to the Operational Intelligence Overview at InsideAnalysis.com. This is a marketplace. We're doing an inside analysis. We're trying to take a look at all the different tools out there for achieving operational intelligence. And today, I'm very excited to have Bill Bain with us, CEO of ScaleOut Software, and he's going to show us ScaleOut Analytics Server. And I can tell you, we just took a briefing, and it's very interesting and very compelling stuff. So with that, Bill, I'm going to hand it over to you to show us what you got.
Okay. Well, thank you very much. Appreciate the opportunity to give a demo. And let me start by showing you what's called an in-memory data grid. This is storing of data in memory across a set of servers to give you scalable access to data and the ability to perform operations on that data very, very quickly. And this allows you to host data in the grid for real-time analytics. What does that mean? That means that as data is flowing through a live system during the course of a workday, that data can be quickly stored in memory and then analyzed in real time to give people that need to make decisions, strategy decisions, the ability to react quickly to changes in the data, and to allow them to look at large data sets that are being stored and to compare how the new data stream is affecting the history that's held in those large data sets. So what we're looking at here is called the ScaleOut State Server console. And this is a product that we have called ScaleOut State Server, holding data in memory across, in this case, 6 servers here. So you're looking on the left-hand side here at the status of 6 servers, green lights. They're all running. And then we can see that the store is holding about 21 megabytes of data. This is a small data set held in 2,000 objects held in the store. Now, this data is being analyzed in real time, as you can see here. So every time the graph goes up, there's a real-time analysis going on to this data. And while the data is being updated in real time at the same time as a market feed comes in, and I'll explain that in just a minute. But first of all, let me show you what's in the grid itself. So this is what we call the ScaleOut Object Browser. And this lets you look in the data in the grid and see what are the objects being stored. On the left-hand side, you see namespaces. These are groups of logically related objects. And the ones we care about here are called strategies objects. They're in the strategies cache. And so we can look at the various strategy objects in the cache, and then we can drill down and actually look at the various components or properties of those objects. So now let's look at what we're doing with this application, and we'll come back to the grid, to the object browser, and see what these objects have in them and why that's interesting. So here is a demonstration console. This is meant as a proof of concept for a hedge fund. And what it's doing is it's holding a set of hedging strategies. Now, because the hedge fund company that we're doing this for doesn't really want to let anybody know their proprietary strategies, this represents a model of the hedging strategies that they would hold in their grid. That's why these are unnamed strategies on the left. But we're holding in the grid something like 2,000, in fact, 2,000 strategies. And we're just displaying the top 100 here. Now, so if we go back and look at the store, then we can see here that in fact there are 2,002 objects. There are 2 other objects unrelated to this demonstration that are being held in the grid as well. So these 2,000 strategies represent positions that each strategy holds. So for example, you might have a strategy for the automobile industry, and you would hold some stocks in long positions and others in short positions. So let's look at strategy 003 here. And you can see here a list of positions that are being held, and you're looking at the target allocation and then the exposure they have based on the current market prices. So at the same time this is going on, a market feed is feeding in changes to market prices, and this represents a snapshot at this point in time of the exposure in this strategy based on a live market feed. Now, of course, in this proof of concept, we have a simulated live market feed, not the actual market feed going on today. And then what we're doing here is we're analyzing, as the market feed is updating all of these positions, and it's updating 40,000 positions, so we have 20 positions per strategy, 10 positions per strategy on long side and 10 more on the short side. And so that's how we get to 40,000 positions total. And so it's able to update them all with 1,000 market price changes per second, and then to evaluate all 40,000 positions within 1 second. So going back to the chart here, you can see that it's evaluating them once per second. As I'm manipulating the browser, it's going to change how this looks, because that changes the graph as we're accessing the grid through the browser. So in any case, what we're doing is within 1 second, we're able to look at all 2,000 positions and make a decision whether or not we need to create an alert for a trader to see. Now the yellow, if you can see the yellow highlights, they indicate those strategies which have been alerted because of a market price change. There's one of these positions is outside of the target allocation, and you can control the percentage, the threshold up here for where you want to be notified of a change that has to be alerted and replied and told to a broker so that he can make a decision as to whether to trade that position. So the key thing to observe here is that we're holding a large amount of data in the grid, and of course this is just a simple example. We've done examples holding a terabyte of data in a grid and doing this whole analysis in 4 seconds on 75 servers. We did this on Amazon Web Services, EC2, and so this scales up automatically and dynamically so that the throughput will grow as the amount of data you have to process grows, and as the time in which you need to get that work done gets increasingly tight. So just one more look at the object browser here, and now it might make sense what these objects represent. So we're looking now at the actual data being held for one of these strategy positions, in this case strategy 1000. And you can see the various properties of that strategy, and then you can look at the positions and see position 0 and it's the ticker symbol and all of the properties related to that. And this is the actual data in the grid at this point in time. And so you can browse all of the data in the grid, you can observe its performance and manage the grid itself, and then of course this is what the object of the real-time analytics is to very quickly update a large data set based on a real-time data feed and to provide alerts when action needs to be taken. And this is something that this technology we're working today to bring to the Hadoop ecosystem so that you can employ the Hadoop MapReduce algorithm to do this very same problem, to handle this problem and produce these results. So thank you very much.
Sure, and if you don't mind, I'll just throw a couple quick questions over to you. So I actually follow the risk management space pretty closely, and we're following the enterprise software space very closely as well. And of course, you remember when the housing crisis occurred, basically when the market meltdown took place. There's a very famous story about Goldman Sachs kind of pulling the trigger on lowering the mark-to-market value of some of their positions in the subprime space. And this whole cascading effect occurred sort of like dominoes knocking each other over, and just brought the entire market down. I mean, it was, of course, disastrous, and it's what resulted in this huge TARP program, the Troubled Asset Relief Program, coming into play. And what I've heard from sources on the inside is that Goldman Sachs was able to do an assessment of their entire portfolio, I think it was every 15 minutes. And I'm aware of the products that they were using. I don't want to mention them on this call. But if I'm understanding what you're talking about correctly, what you are able to empower companies with is the ability to do not just every 15 minutes, but almost like constantly real time. Is that right?
That's right. In fact, that was ironically the call to arms for from the hedging company, which is that this data is being stored in a database server today, and so they can react usually within 30 minutes to an hour, but they like to get that down to a few seconds, and that's why they're very interested in in-memory computing.
Yeah, this is, well, just so we get a little bit more detail in the actual recording, can you kind of talk about how it is that you're able to leverage Hadoop? You mentioned in the presentation before we hit the record button, but can you kind of offer some more context on what you are able to do to enable this with respect to using MapReduce and Hadoop and all that?
Well, in the current release of ScaleOut H server, which is not being shown here, this is ScaleOut Analytics server, we're able to move the data from HDFS into memory. So at least you would have the ability to look at this data in memory and to move it into Hadoop for analysis. Let me go back to the browser here. So this data that we're showing here could now be available for Hadoop MapReduce directly. Now, if Hadoop MapReduce were sufficiently fast and could produce results and collect the results sufficiently quickly, then you could get the same effect with Hadoop MapReduce as you do with the ScaleOut Analytics server parallel method invocation engine, which we're looking at today. So what we've enabled with H server is the ability to access these objects. Now, a point I made earlier that we can actually look at here is you notice each object here in the grid would be read into Hadoop's mappers as a key value pair. And you notice these are fairly hefty objects.
Right.
These objects have a lot of properties, and so they can become quite large relative to what's customarily analyzed with Hadoop. That said, the model is the same. Whether you're doing running mappers on key value pairs or running our parallel method invocation on these objects in the grid, you get the same result, data parallel computation. And data parallel computation, by the way, is giving you two key benefits. It's not just giving you the analytics. It's not just giving you results that you can use to create alerts. But in this case, it's also updating these positions. So it gives you the ability to update data in parallel. So you can use it to maintain the data set as well as to analyze it and do both simultaneously.
Mm-hmm. That is amazing, amazing stuff. Very quickly, what are some other use cases that you see? Obviously, this makes complete sense. What are some other interesting use cases out there for your clients or your prospects?
Sure. Well, okay. As you look at credit card fraud detection, these could represent, instead of strategies, they could represent active customers. So it could be, if you will, a cache of the most active credit card customers for a given company, and you could hold hundreds of thousands or more such history. So each so-called object here would be, say, the last year's transactions by that customer. Now, as they're put in the grid when they are observed making credit card transactions. So then, as the live feed comes in parallel, you could spray that feed out and look at all of the as you update all of these customer histories, you could in parallel analyze them, perhaps with Hadoop as we go down the road a little bit, so that you could see, is anybody making a sequence of transactions which would trigger an alert for possible fraud? And I learned by talking to Visa a couple of weeks ago, if you go and buy gas and don't buy very much gas, and you immediately go to a big box store and buy some merchandise, that will trigger a fraud alert. So it's that sequence of actions. Now the question is, can you do it for everybody in real time? And then can you get a lot more sophisticated? So you know, well, this guy happens to go and buys gas on Saturday morning and goes to Best Buy. So you know, you can imagine how much more sophisticated you can get with this kind of a tool and still deliver results fast enough that you could alert the retailer and do something about it.
That is pretty impressive stuff. Well, folks, we've been talking to Bill Bain, CEO of ScaleOut Software. You can find more about them at ScaleOutSoftware.com. And I have to say, we've saved one of the best for the last, folks. This is really, really impressive stuff. Thank you so much for your time today.
And thank you very much. Appreciate the opportunity.
Okay, thanks, folks. You've been listening to ScaleOut Software, part of the market overview of operational intelligence at InsideAnalysis.com. Take care, folks. Bye-bye.